Hello. Okay, sorry, I got a little bit cut off. From the first video, right at the ending, I was working on this one, g of f of 8. Okay, so look at the last video to see how this is done. We're plugging in f of 8, x is 8, so we're just plugging that into our function, and our new output is going to be 28. So we're plugging in 28 back into our new function g of x. So this means we're using this. So x is going to be 28 this time. So 2 times 28 minus 5. Do this correctly. 2 times 28 is 56. 56 minus 5 is going to be 51. Okay. So what this means is that this is going to be g of f of 8, and that's going to equal 51. Okay. All right. So the next one, okay, so how would you find f of g of x and g of f of x? So we're taking these same functions. I'm going to copy paste them so I can kind of see it. So how would you find f of g of x and g of f of x? So now, what if I didn't give you values instead? And then instead I had you substitute the expressions. Okay. So when you substitute the expressions here, so we want to take g of x. So this is going to be, so if we're considering f of g of x, what we're doing is we're taking g of x here, and this is going to be our new input. Okay, so I'm plugging this in right here. So this means that's f of 2x. So I'm gonna rewrite this here. Okay, so once we have this, everywhere you see an x, you're going to plug in 2x minus 5. So everywhere you see an x, you're going to plug in 2x minus 5. Okay, so if you had to simplify this, this would be, you have to use distributive property. So 3 times 2x is going to be 6x. 3 times 5 is 15. And then plus 4. So this is going to be 6x minus 11. Okay. So what this means is that f of g of x is going to equal 6x minus 11. So that is how you would answer that. Okay. So the next one, how would you find g of f of x for that one? So let's do the opposite. So g of f of x. So I'm just going to copy this so you guys can kind of see that again. So what we're doing is we're taking f of x. So f of x is our new output. So this becomes 3x plus 4. Okay. So what this means is we look at our function g of x, and everywhere we see an x, we're going to plug in 3x plus 4. So 2 times 3x plus 4 minus 5. Okay, so this here, if I use distributive property, this is going to be 6x. 2 times 4 is going to be 8 minus 5. So if I simplify this down, this is 6x plus 3. Okay, so what this means is g of f of x is going to equal 6x plus 3. So that would be how you answer that question. So if you're finding f of g of x, it's going to be that expression. G of f of x is going to be that expression. Okay, so that's basically how you would go about doing that one. Now let's say we had something a little bit different. So I want to show you this example. Okay, so given f of x is 7x plus 1 and g of x is 3x, you want to find the these functions. Okay, so what you want to do is from here. So this is a little bit different. So what we're going to do is we need to determine f of x. So we know f of x is going to be 7x plus 1. So this means this here, we can substitute this right here. Okay. So now what we need to do is so for everywhere we see an x, here, we're going to substitute this expression 7x plus 1. Okay, so this is going to be, if we have 7x plus 1 here, everywhere we see an x, so this is going to be 7x plus 1. So we're plugging x, you're substituting that there. Okay, so what this becomes is 7 times 7x is going to be 49x. 7 times 1 is going to be 7. And we're left with this 1 on the outside, so plus 1. Simplify this further. This is 49x plus 8. Okay, so what this means is that so we're doing f of x, and that's going to be 49x plus 8. Okay. Next one. Let's say we had g of x. Okay, so I'm just going to delete this. So g of x. So what we're doing here is we're taking our function. So we're taking g of x is 3x. So this means we're substituting this 3x into here. Okay, so 3x gets substituted in there. So I'm just going to rewrite this g of x. Okay, so next what we're doing is, so everywhere we see an x, we're plugging in 3x. So everywhere we see an x here, we're going to substitute 3x. So 3x gets substituted for x. So 3 times 3x is 9x. Okay. So what we're left with is we are left with g of x, and that's going to equal 9x. Okay. So next one, f of g of x. So we're going to do the same idea. So if you guys kind of see a pattern already, g of x here is 3x. So 3x goes there. Next, what we're doing is everywhere we see an x, we're going to plug in 3x. So everywhere we see an x, we're going to plug in 3x. So f of 3x is going to be 7 times 3x plus 1. Okay, so 7 times 3x is going to be 21x. And then this part is on the outside. This doesn't get touched. This is 21x plus 1. So our final result is going to be f of g of x is going to be this expression. So this 21x, 21x plus 1. Okay. And the last example that I have for you guys is going to be this one. So g of f of x. So this means everywhere we see f of x, we're going to plug in 7x plus 1. Okay. Now what we need to do is for everywhere we see an x, we're going to plug in 7x plus 1. Okay. So g of 7x plus 1 is going to equal 3 times 7x plus 1. So to simplify this further, I see we can distribute the 3. This is going to be g of 7x plus 1 equals 21x plus 3. Okay, so this would mean our final result that we have is g of f of x is going to equal 21x plus 3. And that is basically it. Okay, I know I skipped over some of the problems in the middle, but please just let me know if you didn't understand this video. Just ask me just any questions you have on it. I know some of the ones in the middle are a little bit more challenging, but hopefully just by seeing this video, how these things are substituted, you guys have some sort of idea now. Okay, so that is it. This is the last video. Okay, thanks, bye.